This is Timothy, and I'm going to make a beginner's video for the JK BMS so that others can learn how to properly connect this battery management system to a lithium battery like you see in front of me. I'm going to go ahead and explain the battery and how to run through the whole step. This is going to be a video for beginners, so I'm going to explain everything relatively slowly so that everything is understood, because this is a relatively advanced system here. So let's get started. What we have here is two LG batteries. Within each of these packs is two cells, and there are 12 total, with them being in for a total of 24 total cells, and they're put in 3 parallel 8 series. So there's 8 series on this and 8 series on this. These two are the positive, and the negative is here and here. In a previous video, we actually connected the negative to negative with this wire and the positive to positive with this. We put a DC breaker in there, and we allowed them to equalize. So now, when I take my probe leads, we're going to get exactly, well, let's switch it over to, there we go, 30.1 volts, which you can see on camera, and 30.1 volts. This is also, I'm going to turn this guy off, indicated by there is no current flowing between the two cells. So currently with this set to off, click it on, no current. I initially started these parallel connected when there was a difference of 0.2 volts, and that allowed for about 6 amps to flow between two batteries. However, that decreased at a linear rate over the course of the next probably 30 minutes to 0 amps, and they were pretty much balanced out very quickly. So what we're going to do now is we're going to wire the positive is going to go here, which means we're going to take this wire and connect it from this negative to this positive, and then the negative is going to go here and connect to the blue wire of the battery management system, which then connects out to an inverter. So that's what I'm going to do now. So now we're going to go negative to positive. Now we're going to connect this red wire here, which connects to a DC breaker. This DC breaker is in the off position right now. Let's walk around. if we can get it. Yeah, there we go. So now when we measure from the positive to the negative, we get exactly 60.02 volts, which I hope you can see in the camera. Yeah, I can. There we go. 60.2 volts. Excellent. Now for the battery management system, all the leads are labeled B0 through B, 14, and then there's also a 15 and 16, and I have removed leads 17 through 24 because they're not necessary. This is a 16S battery, and the last lead is the B+. This connects to anywhere on the battery as long as the voltage is higher than, I think it was 40 volts. So in that case, it's going to go right there. And this B sub 0 is going to go on the ground. So this is going to be connected to the same place as this blue cable. The blue is the B minus. So this ground right here is the B minus. That's the B minus. So now I'm going to take the B sub 1. Oops. And it's going to get put there. Which means that number 2 is going to go here. Now I added these alligator clips myself, mostly for the aid of connecting and reconnecting, since I'm going to be using this battery management system for troubleshooting different batteries, which is what you see me doing here. It's pretty simple, and I'm just going from one side to the other. Each of these batteries is lined up positive to negative, and then the negative this cell is the positive of this one, and vice versa. Though your pack could be arranged in any way. The other thing I did was I alternated the colors of the leads, so one side is entirely green and the other side is going to be entirely white, so that if I were to make a relatively careless mistake and connect them in such a way that I grab the wrong one, I'd be able to know. Unless I skip 2 leads. Now in this case it's a little tricky since I'm actually connecting the batteries together. So we have this cell here connects to here, which connects to this. So I'm not putting the next lead, which is white, on this side at all. It's going to go over here. Because all of these are connected together already. So just a few more to string up. So relatively low risk at this point. If you do wire it up incorrectly, you or some battery management systems will get quite hot. I haven't wired this one up incorrectly yet, but I would imagine that it could possibly damage it. So now I'm connecting number 14. Right here. And that's the last one on this side here. It's the last one. So now I'm grabbing number 15 here. Oops, I kicked it, but that's all right. And number 16 is actually going to go on the positive. This is the last cell in the series, and it connects to this DC breaker here. So we're going to go ahead and connect it on, and you will notice that absolutely nothing happened. And at this point, the manual is less helpful than you might hope, because it just indicates that once you apply power to this lead, it'll turn on. What you actually need to do is give it at least 5 volts across the difference. So let me eliminate this cable out of the way here. And that tape, neither of which are necessary. Alrighty. So what we're looking at right here is 2 lithium battery packs. Black is positive. No, of course not. Black is negative, red is positive. And for this pack right, is this showing up? Let's see here. Yes. There's 3 batteries. This pack right here is actually entirely ignored. The 2 leads are just covered in tape. For these 2 packs, though, I have the negative and the positive tied together, and then I have the negative and the positive attached to these alligator clips covered in tape so they don't ground each other out. So this gives me 7 volts, which I'm going to show you on the voltmeter. Well, 6.36 volts at least. So I just attach the leads to these. So what we're going to do here is we are going to attach the positive lead here to the positive terminal here. You could also connect it to this B plus wire here. And then we're going to take the negative terminal and we're just going to touch it to the P negative here, and this is going to send a positive 12 volts with the positive wire here and the negative wire here. And what you just heard is our little device turning on right there. So that was it. That was all we needed to do to get this guy to turn on. You cannot rewire any of the cells from this pack in order to turn this on. It needs to come from an external power source. The app name is, oops. Let me try that again with the app name in there. The app name is ENJ Power, and when you hit scan, the battery management system will show up in the list. You want to go ahead and hit connect. And now you can see that all of our cells are, whoa, exactly the same. You almost never get that. In fact, let me show you my other battery that I have so you can see what they more realistically look like. This is the one right behind me. Okay, it's not a perfect app. Yeah, it does crash quite a few times, and it's probably not what I would recommend for a beginner BMS, but it will eventually work. This is the one we just did. I'm still trying to bring my other one up. You can switch between multiples. There we go. Just took a little bit. So this is what we should be expecting, whereas the cells are pretty close to each other, but not 100%. And you can see there my delta is still actually just 0.09, which is amazing. And this one right here is currently balancing the cells. Rather, it's taking 2 amps and putting it into cell number 6, whereas the total pack amperage pull is a little over 20 amps there. So these are the numbers that we're looking at here. Pretty good, actually. I'm really hoping to get about 9 kilowatt hours out of this pack, but let's go ahead and skip back to the tutorial. So we're going to go ahead and put in the settings here. The password for this is 1, 2, 3, 4, 5, 6, verify. Oops. Maybe I... Now I'm allowed to change the settings. We're going to go ahead and change the cell count to 16, hit OK. Change the battery capacity to 180 amp hours, hit OK. Let's see here. We're going to modify these values at a later time, but this is where you would change all of these settings. We're going to change the max discharge to 50 just to limit it during this test, and we will be making no other changes at this time other than to take this temperature sensor right here, and I'm going to heat it up in my hand by holding it, and you can see that the temperature sensor is warming up. I'm holding T2 in my hand, and it's heating up to 33 degrees Celsius, whereas in T24, which is this one right here, if I hold it in my hand, you're going to see it heat up as well. So it is functioning. We'll do hot and cold temperature confirmation tests later on. But now we have the entire battery management system up and running. Now you will notice at the top that charge and discharge are off. So if I go to turn my inverter on, nothing's going to happen. So if I go ahead and click on this guy right here, just turned on my breaker, I'm still not going to get anything. I have to go to control, and I have to turn charge on and discharge on. And my inverter actually kicked on, but it's very quiet, so you can't actually hear it. But it's on. I'm going to go through some of the settings and controls for this battery the best I can. One of the nice things about this is that you cannot modify any of the settings accidentally without the password, which is 1, 2, 3, 4, 5, 6. let's go down to advanced settings. Now all of these settings will be custom. For these particular LG cells, I'm actually going to do a relatively low voltage cutoff and low high voltage cutoff. So we're going to go ahead and set this value right here to 3.1, and we're going to set this to 3.15. And you say that it actually failed. Now the reason for that is this is under voltage protection and under voltage protection recovery. What this means is that you under voltage protection would have this thing triggering off at 3.15 and then triggering back on at 3.1. It doesn't work that way. You have to have it trigger on at a higher voltage. The recovery is going to be higher in this case. So the way to do that is to actually set this to 3.0, and then you're going to see it's just going to beep OK because it's a valid setting. So it's not allowing you to do an incorrect setting. So for this one right here, the over voltage protection for this is going to be 4.1. And you see it failed because they're the same value. So I have to set the recovery to 4.07. And now everything is appropriate. The power off voltage is the voltage at which this little light's going to turn off and the BMS is going to stop functioning, because the BMS actually does draw a small amount of power. And if you were to just leave this battery alone for months on end, eventually this BMS would drain it down below the threshold voltage, which is why we have the ability to use a secondary battery to wake this thing up again. And that's currently going to shut it off at about 2.8, and that's probably going to be appropriate, because even though I don't want these cells to get down lower than 2.8, because that's definitely when they're going to get damaged, it would probably be okay to keep this battery management system on, since I'm imagining it's not going to be kept there very long. But if I chose to, I could definitely jump this up to 2.95, and then pretty much right after it shuts off, it would shut this thing off. That would be a pretty poor choice. But it's definitely something you could do depending on your situation. This is the max charge current. Depending on which one you get, you actually have different charge and discharge capacities that they're rated for. And I'm unsure if the capacity that they rated at is a surge capacity, or if that is the continuous. But I typically buy the one that is about twice the amps as I plan on using, because in that case you know it's going to be very happy just at a 50% load. But you could go ahead and change this to say, well, more accurately, this is a 125 amp breaker, which means that it'll trip at 156 amps, which is the rated value plus 20%. I don't really want this to ever trip. I want this to trip because this is a MOSFET trip, and it's going to automatically reset itself based on these other values, whereas this is going to require manual intervention. So I definitely want to have this value set lower than the value of the manual breaker. The value of the manual breaker is simply a secondary failover in the event that this does not work. But for testing purposes, with the thickness of this wire, we're actually just going to set this to 50 amps. The next value is the over current protection delay. After you do pull that many amps, it's going to shut itself down for 30 seconds. Or actually, I believe, no, I am incorrect. The OCP delay is the amount of time that it can surge, and the recovery is the amount of time that it's off. I've only got to play with these settings a few times, though. Let's see here. The mag, that's self-explanatory. These are the temperature settings for the battery. They have both a charge high and a charge low, as well as a discharge high. So for my particular battery, I'm going to set the protection recovery to be 4 40, I'm going to say 40 degrees Celsius because it really shouldn't be that high. And you see it aired me out there because my recovery needs to be lower. So if I set this to 35, then this can be 40. And we'll do the same for discharge and charge values, but they are actually different for these batteries. I believe that the charge value can go up to 45, whereas the discharge is still limited to 40, but I'm going to keep them the same for the time being. And in terms of these negative values, I'm going to have this recover at 5 degrees and turn off at 0 degrees. So to reiterate what we're doing here, we're going to have this charging over temperature protection is set to 40 degrees Celsius, which is around 122. And then it's going to recover at around, I think it's 113 degrees. Same values for discharge. And then in terms of cold temperature, it's going to stop charging at 0 degrees and only start charging again once it hits 5 degrees. And these two values are the over temperature protection for this unit itself, which has a default value of 90 and 70. I would probably lower that or rather I'm going to lower that just for testing and monitoring, but you should actually determine how hot the batteries can get and what type of performance degradation you get, because certain batteries can handle higher temperatures and or lower temperatures, and you can adjust these values accordingly because this is a very flexible system. And that's about all the settings. There is no Coulomb counter, and it has been incredibly accurate so far. I am going to go ahead and pause this, and just so you can see the system doing some different functions with this BMS here. So we are currently charging at a 20 amp rate. It's actually listed as 18.3, 18.8, 19. Pretty close. So now it's charging right now, and you can actually see that it is actually balancing the cells. This particular one balances at 0.6 amps, which is why it's the maximum. I have another model that I showed earlier that balances at 2 amps, and that extra bit of balancing is ideal for testing to ensure that all of the cells actually do balance them out, because resistive testing first off is typically only done when the cells are nearly full, and sometimes with a pack that's out of balance you'll never actually get all of the cells full. Additionally, it's also relatively weak. At a 2 amp rate you're going to get some balancing. On cells like these, yeah, it's going to take a week, but it is going to get balanced. And that's the important factor here that we're looking at. And in this particular case, the balancing would be, well, I guess it would automatically top balance or bottom balance your pack. It actually balances it the whole way through, so you just give it a little bit of time and everything will even out. But this is it right here. Oh, let's go ahead and show that you can actually cut the charge. See if you could hear that or not, but there we go. We just manually cut the charge, but we kept the inverter on. Go ahead and turn the charge back on. And you can hear it. So, full Bluetooth control of charge and discharge from the system itself. So we can go ahead and actually, I believe if we cut discharge, the whole thing will shut off. No, the entire thing does stay on, but this is actually just a factor of my inverter because we're currently plugged into shore power with the battery disconnected, which is what would happen during a very high discharge or charging cycle. Let's assume you're rapid charging it and maybe you have the vent fan closed, or yeah, the vent fan hole is blocked or something and it's just not getting enough airflow. It'll actually stop the discharge process, but everything will stay functioning. Like the inverter is still running right now because I'm not pulling enough of a load on it that actually requires a discharge from the battery, so it'll stay running. So in my systems, you can actually turn the discharge off and back on again, and everything will stay running like you don't even notice it. We can go ahead and turn that back on. And you can hear the inverter stayed running the whole time because we're currently charging. And if we go here and we actually cut charging and we cut discharge, you actually hear it boom, cut off fully because we turned off both of them. So it does function with one or the other. And that allows you to... Well, that's what allows this thing to work the way it does in a really automated and pretty much fantastic way. Just like the other similar BMSs. And you can see as I turn them back on, inverter automatically kicks back on again. And if I hurry up, it takes a couple seconds for the automatic transfer switch and everything to kick on, and it gives you time to see everything turn on and off. So full control from your phone over Bluetooth. The range is very weak. I would say probably 10 feet, 20 feet. Let's see here. Other features. There is no other manual way to turn this device on other than by applying 5 volts with the positive here and the negative to this terminal here, which I exposed for this video.